Now let's explore more examples. Activity 1.6 uses lead nitrate. We will take about 2 grams of lead nitrate powder in a test tube. Notice it's a white crystalline powder. Important safety note: lead compounds are toxic, so we must handle them with extreme care and ensure proper ventilation. Now I am heating the lead nitrate carefully with tongs, pointing the tube away from everyone.
Professor, I can hear a crackling sound coming from the test tube.
And look, brown fumes are being released from the tube.
Excellent observations. Those brown fumes are nitrogen dioxide gas. No, very characteristic color. After heating, notice the yellow solid residue left behind. This is lead oxide, PbO. The complete equation shows lead nitrate decomposing into lead oxide, nitrogen dioxide, and oxygen gas.
So again, one reactant broke down into 3 different products. That's definitely a decomposition reaction.
Perfect. Now let's see decomposition caused by a different energy source: electricity. Activity 1.7 Electrolysis of water. We have carbon electrodes in water with a few drops of sulfuric acid connected to a 6-volt battery.
Professor, I can see bubbles forming at both electrodes as soon as we switch on the current.
Watched carefully, we are collecting the gases in inverted test tubes. Notice the different volumes being produced.
The cathode is producing about double the volume of gas compared to the anode.
Now, for the exciting part: testing these gases with a burning candle. Remember, only teachers should perform this test. The gas from the cathode burns with a distinctive pop sound. This confirms it's hydrogen gas. The gas from the anode makes a glowing splinter burst into flame. This confirms it's oxygen gas. So electricity decomposes water into hydrogen and oxygen in a 2:1 ratio, matching the water formula perfectly.
So electricity can break down compounds too, not just heat. This is called electrolytic decomposition.
Excellent understanding. Now let's see decomposition by light energy. Activity 1.8 uses silver chloride. We place white silver chloride powder in a china dish and expose it to bright sunlight.
Professor, the white powder is slowly turning gray in the sunlight.
This is photolytic decomposition. Light energy breaks silver chloride into metallic silver and chlorine gas.
Wait, is this how old cameras worked? Using silver compounds that change in light.
Brilliant connection. Arjun, yes, silver bromide and silver chloride were used in black and white photography films. So we have seen 3 different energy sources that can cause decomposition: heat, electricity, and light energy.
I noticed that all decomposition reactions need energy input to break the chemical bonds.
Perfect observation. Reactions that absorb energy are called endothermic reactions, the opposite of exothermic. Let's test this. I am mixing barium hydroxide with ammonium chloride. Touch the bottom of the test tube.
The test tube feels cold. The reaction is absorbing heat from the surroundings.
Exactly. When a reaction makes the container feel cold, it's absorbing heat, definitely endothermic. Today we explored 3 types of decomposition: thermal by heat, electrolytic by electricity, and photolytic by light.
Different forms of energy, but they all achieve the same result: breaking compounds into simpler substances.
These decomposition reactions have real applications: water splitting for hydrogen fuel, photography, and many industrial processes.
chemistry is amazing. There are so many different ways to break compounds apart using different forms of energy.
Remember, decomposition reactions are typically endothermic, they absorb energy. Combination reactions are usually exothermic, they release energy. Excellent work on decomposition. Next, we'll explore oxidation, when substances react with oxygen or lose electrons in daily life.